So physical quantity of is anything which can be measurable. It is a it is measurable, and it have units. There are two types of physical quantities. First one is fundamental, and the second one is first one is fundamental physical quantity, and the second one is derived physical quantity. Okay, derived physical quantity. So let's see the definition. I'll give you the small definition of it. So let's take this is the definition. Okay, the physical quantity, you can note down this definition. A physical quantity is any property of material which can be measured and expressed numerically with the help of any unit. There are two types, fundamental and derived. Fundamental physical quantity is independent physical quantity. There are seven fundamental physical quantities are there. We will see them. Derived physical quantity, which is dependent on fundamental physical quantity, and we can obtain it units, dimensional formula. Let's see first one. Fundamental physical quantity. This is most important. There are seven fundamental physical quantities we have, and two there are seven fundamental physical quantities. Okay, fundamental physical quantities. The first one, mass, very very important. Mass, its units are SI unit is kg, its dimensional formula capital M. Length, SI unit is meter, dimensional formula capital L. Time, SI unit seconds, dimensional formula T. Electric current, SI unit is ampere, dimensional formula A also you can represent, I also you are represent. Okay. Temperature, dimensional SI unit Kelvin, dimensional formula K. Luminous intensity of light, SI unit is candela, and CD we represent, amount of substance mole, MOL we represent. And most importantly, two supplementary quantities are there. The first one is plane angle, and the last one is solid angle. A circle you take. Here is the center. The body starts from this point and reach it to this point P after some time. Okay. This is started from A and reach it to B. How much angle it is covered, we call it as plane angle theta. So plane angle plane angle formula theta is equal to, this is arc, this is the arc, it is covered x distance, and radius is capital R. So theta is equal to arc by radius. So both are arc by radius is there. So its units are radians. SI unit is radians, and dimensional formula, no dimensional formula, because L and L get cancel each other. And the solid angle, next one we will see solid angle. So the angle will be right, it is the how much angle it is covered. So this angle is called as solid angle. Okay, solid angle is equal to formula, this area you see it is covered, this area A, how much area covered is capital A, area by R square, R is the radius. Okay, so again you see it's dimensionless formula. Area, we will see that steradian and represent with SR, radian RAD, no dimensional formula. These two are very important. Plane angle, solid angle do not have any dimensional formula. Now coming to the, see, a quantity which is dependent on fundamental quantity are called derived quantities. So it's dependent on fundamental, right? Like most very very important. See, some dimensional formulas I will tell that you have to remember. Like first one, area. Area formula, general S square, L square, L into B, right? Its units are meter square are the units, and dimensional formula, length dimensional formula L power 2. See, this is formula, SI unit, and dimensional formula. In the same way, volume. Volume formula LBH, L cube. See, L into B into H, meter into meter into meter, meter cube is the units, and dimensional formula capital L power 3 is the dimensional formula. Speed, or velocity. You can also call it as velocity. Its formula: displacement by time, a change in displacement by change in time, distance by time. It's SI unit. Distance SI unit meter, time SI unit seconds. Okay, and its dimensional formula very important. Length is L, time is T. So it becomes L power 1 T power minus 1. Next, acceleration A. Its formula is velocity by time. Velocity dimensional formula now only we did L power 1. Okay, it's units. It is meter per second and one more second there. So what it becomes? Very important, you should remember this: meter per second square. In entire physics we will use this. And dimensional formula, you see, velocity dimensional formula L power 1 T power minus 1. Just now we did by time T power 1. Again the T power 1 will go up, it becomes L power 1 T power minus 2 is the acceleration. Okay. And now force. Force formula MA. Okay. M units, SI unit is kg. Acceleration now only we did meter per second square. So kg meter per second square, and force most importantly Newton as is the SI unit. Its dimensional formula: see, mass into acceleration. Mass kg. So m power 1 is the dimensional formula. Acceleration dimensional formula L power 1 T power minus 2. Very important. You must remember this. Energy. Energy means it can be potential energy, it can be kinetic energy, okay, it can be heat energy, any kind of energy, rotational energy. So if the term energy comes, then you can use this. It is force into displacement. Like one more there, torque. Torque also almost like same formula, force into perpendicular distance. So yes, also distance, displacement here. Dimensionally they are equal. So we are discussing dimensional formula. So torque also have same dimensional formula. So force now only we did it is Newton are the units, displacement meter, Newton meter, and most important units are energy means joules you can use, or Newton meter you can use. Okay, dimensional formula. Force dimensional formula m power 1 L power 1 T power minus 2 into one more displacement L power 1. So what it becomes? M power 1 L power 2 T power minus 2. Then one more derived quantity power. Power formula work by time. Okay. Work, or here work also you can write. Work, okay, same dimensional formula. So work dimensional formula m power 1 L power 2 T power minus 2 by time T power 1. So finally what it becomes? M power 1 L power 2 T power minus 3. Its units. Its units are joule per second you can write, or most importantly watt, or its SI unit. We want dimensional formula of B by mu naught. We know the formula, B is equal to mu naught Ni, and this formula is for solenoid magnetic field. Here we want B by mu naught dimensional formula. Here N is number of turns per unit length, so we can say capital N by L I. N is a constant, so we want dimensional formula of B by mu naught is equal to, N is a constant, you can remove the constant dimensional formula, there is no dimensional formula for a constant. So N dimensional formula is ampere by L. So finally it is A power N, A power 1, L power minus 1. So option 2 is the correct answer. Question is given in 2025 JEE mains paper. Let's solve it. Find the dimensional formula of capacitance. So simple question, right? C is equal to basic formula Q by V, we will think. Q is not a fundamental unit. So charge formula we know, current is equal to rate of change of charge, right? How much charge is flowing per unit time. So Q is equal to, I can write it as I into T. So we can write it as I into T. Both are fundamental units. V is voltage. V basic formula we know, W by Q. W by Q. V is equal to work done
to move a charge from one point to other point. Correct. So V you can replace with the W by Q, and Q you can replace with I into T again. Q will replace with the I into T. So you can write it as W by Q will go up. It becomes I into T. So again here I into T you can write. Fine, fantastic. So Q dimensional formula you will get, right? I is ampere, ampere power 1, 2 there, 1 plus 1, 2 ampere square time square by, this is work dimensional formula, m power 1 L power 2 T power minus 2. You can directly take it or you can calculate it. Basic formula work is equal to force into displacement, force formula ma into displacement, m is m power 1, acceleration L power 1 by T power 2 and length L power 1. So what it becomes, m power 1 L power 2 T power minus 2. Simply substitute here. So m power 1 L power 2 T power minus 2. So finally m power minus 1 L power minus 2 and T power minus 2 plus 2, minus 2 will go up plus 2 plus 2 plus 2, it becomes plus 4 and A power 2. So this will be the dimensional formula of your capacitor. Okay. So let's check the option. A square, here A cube there wrong, A square T power 4. So this is the answer, m power minus 1 L power minus 2 T power plus 4 A square. Thanks for watching. Check out for next video. I am Muhiddin.